Okay. For the async class that I have assigned everyone to watch all the videos, that will include all these 5 videos for the probability of binomial distribution, data science and statistics, relationship between whatever things. As far as this video is concerned, all the contents reflect the materials that I'm going to teach in this class. Okay, so basically the learning objective, we identify whether random variable, okay, this one, okay, identify whether a random variable is a discrete or continuous. Second, define probability distribution of a random variable. Differentiate between binomial and Poisson discrete probability distribution and their application, and apply Poisson approximation to binomial random variable, and why do we approximate. But for this class, I think I would be able to complete until number 6, okay, until 5 and 6 only, because I believe I need to make sure that everyone understand the whole content of the first discrete probability distribution that will be on binomial. Okay, since it will involve few concepts and what we call very simple theory, I would say, for you to understand in order to what we call easily understand the whole chapter 2. Okay, because chapter 2 deals with probability distribution function. Okay. I know I have given you few questions regarding simple questions for what we call probability distribution function, random variable, and whatsoever related in the what we call attendance form. But as for now, remind me to discuss that at the end of the what we call at the end of the lecture. Okay. Now, what is a discrete probability distribution function? So if you look at your big topic, is the probability distribution. So we will have two types of probability distribution. The first one is what we call discrete probability distribution, and the second one is continuous probability distribution. Why do we need these two, and why do we need to understand at least this is what we call the basic, okay, of probability distribution. There are many other types of probability distribution functions available out there, but as for you to get what we call the fundamental of probability distribution, usually these two will be covered. Okay. Now, what is discrete probability distribution? Okay. When we say discrete probability distribution, means that we are going back to the experiment that we do. Okay. So there will be some criteria that we can call as discrete probability distribution. Okay. So before we go deeper, okay, let's look at the few fundamentals about probability distribution. We begin with the random variable. Okay. So if you remember last time we talked about skewer, we talked about X, okay, and those X could be referring to weight, height, or for the skewer project, we refer to the length of skewer. So all these are called variable last time. We call it as variable. Now, why random variable? Last time I said it is because there are some randomness criteria for each and every variables that we are discussing. Okay, so the main point here, remember, when we have random variable, that random variable is denoted as X, or sometimes we call it as Y, or whatever may be Z. It depends on the defined variable for this particular random variable. Okay, and is a variable whose value are determined by chance. Means that is why we call it random, because the outcome will be determined by chance. Okay, if we are talking about hitting a coin, tossing a coin, we know we have what we call equally uh, uh, coins with equally likely to be, to get one of the set, whether the head or tail, which is 0.5 for each probability, means that there will be some probability or some probabilistic nature that involved in the experiment. Okay. Now, what about discrete random variable? Now we know that generally we have random variable. Before we have random variable, we call it as variable. Now, after random variable, we can classify them into either discrete or continuous. What about discrete? Discrete, a random variable that takes only certain value, means that only takes exact value along an interval with the possible value having gaps between them. Means that you can have the value as 0, 1, 2, 3, 4, 5, but not 0.5, 3.5, no. Okay. But for continuous random variable, it will be the reverse of the discrete random variable. But because when we have discrete random variable, okay, fine, I have variable that follow the discrete criteria. What if I have experiment where I don't have the criteria that follow the discrete? So that will be falls under what we call continuous random variable. So what is continuous random variable? It's a random variable that takes a value at any point along the interval. Means that if it is discrete, exact value taken 0, 1, 2, 3, etc. But for continuous, it could be any value of the interval. It could be 0, it could be 0.7, 0.9, whatsoever. Okay? And it may include, for example, maybe 3. Okay? But later we'll see how. Okay? Now, what will be the two types of random variables that we have discussed just now? What are the examples for each of them? Okay, for the discrete random variable, exact value, last time I think I have mentioned this, so I will go through very quick. Number of sales, exact value. Number of calls, exact value. Share of stock, exact value. People in line, exact value. Mistake per page, we can count that. So exact value. And in reverse, we have continuous random variable. Length, it could be 1.7 cm, 1.5 meter. Depth, the same. Okay. It can be any values on the interval. Volume also the same. Time can be 1.5 hours, 1.3 hours, so on and so forth. The same with weight. Okay. Now, let's go into detail what is discrete probability distribution. And basically, this what we call discrete probability distribution is following what we have discussed before. Okay. So a discrete probability distribution consists of possible value of for possible values, a discrete random variable can assume and their corresponding probability. Means that x can be 0, 1, 2, 3, 4, 5, 6 until whatever number. But this exact value has its own probability. If I get x is equal to 0, so there will be probability involved in that. If x is equal to 1, there will be certain probability for x is equal to 1. The same goes to x is equal to 2, x is equal to 3, and so on and so forth. Okay, now let's begin defining our x discrete probability distribution. Can someone give response? Is everything clear so far?
Clear, clear.
Okay, clear. Okay, thank you. Now, let x be a discrete random variable. Now, we have in mind it is a discrete. Okay, what are the things about discrete? Later we'll see. But fundamentally, okay, let's define x as a discrete random variable. So we can say p x is equal to small x. So this is the terms that you are going to use in terms of the probability of this x random variable taking a value of small x. So how do we read Px is equal to x is read as probability of x exactly equal to x. So this is the easiest way to see. Okay, so probability of x is equal to x is actually the probability of x exactly equal to x. Small x is okay, what? An exact value. As I mentioned just now, 0, 1, 2, 3, 4, and so on and so on. Okay, then a discrete probability distribution must satisfy these two conditions. First, as what we have discussed before, the probability value can be from 0 and the maximum of probability. So the probability value is between 0 and 1. Second, the sum of all the probabilities is equal to 1. So I have all the x. If I add all the probability of each x that we have in our experiment, the sum of all the probability should equal to 1. So these are the two criteria for discrete probability distribution. Okay, so this probability distribution, okay, can be in the form of a table, graph, or mathematical formula, okay, which specify all the possible outcomes and the associated probability. Means that in the table, in the graph, or in the mathematical formula, you can see the element of possible outcomes, and the second one is the probability value. Okay, let us see the first one, discrete probability distribution in terms of table. So this is an example of 2.1 that we have discussed about having a child considered as having boy in the three siblings family. Okay, so this is what we call the probability of x. The random variable is what is for the example 2.1. The x is having boy in the family. Okay, specifically look into your textbook. Okay, but easily say based on this table, you can say x is the for the random variable x defined as having boy in the family. So in this case, we have 3 girls, so no boy, so the x is equal to 0. See, this small x refers to the value taken by each of the random variables here. From the second, what we call combination, first level, second level, third level, or first child, second child, third child, we can see there will be one boy in the family with the probability of 3/8. One boy, two boy, and maximum, if you are talking about 3 siblings, maximum there will be 3 boys in the family. So we have all the corresponding probability for each of the values of x that we have in the experiment. So this is what we call table. Now the second one is what we call the graph. Okay, so in this graph we can clearly see the number of boys, 0 boy, 1 boy, 2 boys, 3 boys, and we have the probabilities in the y-axis, and we can see what will be the probability for each of the event or outcome. Okay, so these are the so graph okay, so these are the common forms of what we call probability distribution that commonly used in statistics. Okay, if you have any question, you can stop me, class. Okay, now probability distribution can be divided into two, as I mentioned earlier. We have discrete, we have continuous. So under discrete, we have binomial, then we have Poisson, and then we have Poisson approximation of binomial. Okay, so for today's class, I'm going to finish this because it involves what we call few concepts that I need to make sure everyone understand the whole concept, the fundamental concept in order for you to understand chapter 2. Okay? Now, we begin with the binomial probability distribution. Before this, I said about discrete probability distribution. The random variable x will be taking an exact value. Okay? And knowing that a discrete will fulfill two criteria, the probability is between 0 and 1. The sum of all the probabilities will be equal to 1. But what will be the criteria for what we call as binomial probability distribution? Now, for example, binomial experiment. So when we say binomial probability distribution, means that we have binomial experiment. Okay. So what are the example of what we call binomial experiment? For example, tossing a coin, baby born, football game, true or false, multiple choice question. How this become binomial then? Look at the possible outcomes. Okay, what can you observe from the possible outcome? For example, tossing a coin, you can have head or tail. Baby born, you can either have male or female. Football game, if we classify using win or lose, then we have two outcomes here, win or lose. Or true false, we have true false answer. And finally, multiple choice question, if we wish to define as correct and incorrect. So what you can observe here involve what? Two outcomes. This is the most obvious that you can observe from the outcomes of each of the binomial experiment. Now, in the video last time, I think one of the video also mentioned about Bernoulli. Okay, so what is the difference between Bernoulli experiment and binomial experiment? Can someone comment before I give my comment? What is the difference between Bernoulli and binomial? Or if you don't want to say about the difference, you can say about the similarity. Someone? Class?
Bernoulli is just for one trial. Binomial is all the trials.
Oh, all the trials, okay. Good attempts. Yes, Bernoulli involve only one trial. But binomial involve n trial. Okay, so Bernoulli and binomial will have two outcomes. They will have two outcomes. So whatever outcome it is, it will be defined under two outcomes. What are the outcomes depends on how the researcher defines. But in terms of the difference between Bernoulli and binomial involve n trials. Okay, so there will be more than one trial. Bernoulli only one trial. Now, so let us see in specific what are the criteria for binomial probability distribution. Okay, an experiment in which satisfy the following characteristic is called a binomial experiment. What are the characteristics? Make sure they will have four different criteria. The first one is the random experiment consists of n identical trials. If you are saying about what we call flipping a coin, so there will be 10 times of flipping a coins. Okay, for example, answering the true false questions. Okay, when we say identical trial, means that the outcome will result to the two outcomes. So it means that we have identical trial. So the trial will lead you to same outcome, two outcomes only. Second one, each trial can result in one of the following outcomes. Means that you have two outcomes. So what are the outcomes? One is what we call as success. The other one is failure. Okay? But the one defined for binomial is always be the success. Okay? Success will be considered for your binomial experiment. But if the failure is considered as the success, there will be times where the failure can be defined as the success. It depends on what is the given question in your questions. Okay, later we'll see. But as far as this criteria is concerned, just know that there will be two outcomes. One is success, the other one is failure. Okay? So success, what types of success is depend on how the researcher define the success. The third one, there will be n identical, n trial. The n trial are all independent. Means that the outcome of all the trial is not affected by the outcome of any other trial. The first trial will not affect the second trial. The second trial will not affect the third trial. Go on and on until the end trial. Okay, so this is what we call trial are independent. Now, the last one will be the probability of success is constant from trial to trial, and we denote the probability by P. So this is the probability value. Okay, so usually the probability value will be given in your questions. Okay, so I hope everyone can understand the 4 criteria for what we call any random variable that follow binomial probability distribution. Must have all these 4 criteria fulfilled. Must be fulfilled. Each and every 4 criteria. Okay. Now, let us look at the example. Okay. A coin is flipped 10 times and the count of hits and count the hit number of hits. Okay. So in this case, you have 10 identical trials. Okay. And we know the outcomes will be is either hit or tail. 2 outcomes. And when you toss the coins from first toss until the 10th toss, there will be independent trial. Okay, so means that every toss will not affect the other tossing coins. And the probability of success is getting the hit remain constant in 10 trial, that is 0.5. Means that the first trial you pick the coins, the probability of success is 0.5. Second trial, pick the coins again, the probability of success is 0.5. Third flip is 0.5 until your 10th trial is also 0.5. Okay, so in this case, what is your random variable here, class? I know I have discussed this. I just want to hear from you. What is the random variable defined in this particular example, class? Class?
Head and tail.
No. Only one. Only one. The example say a coin is flipped 10 times and count the number of hits. So this is your hint for your random variable. Consider your success. So X is the number of getting hit. So this is considered as success. Okay, so that's why the probability of success is equal to 0.5. Success of what? Getting the X. Okay, X is equal to any hit counted for each tossing coin. So it will be considered as your success. And the probability of success is 0.5. Okay, now in terms of notation, okay, class, there will be many notation used in this chapter in terms of probability. So make sure the way you write the probability, the random variable, the distribution, and etc. is according to the right format. Okay. For example, n refers to the number of fixed trial. In this case, your n is equal to 10. Okay. X is the number of success in trial where X can be from 0 until, in this case, is 10. So your X will be this one, the number of getting hit. probability of S is equal to P, whereby the P is identified as 0.5 of getting the hit. Okay. Probability of failure, P of F is equal to, we know that the total probability is 1. So what will be the probability of failure? It will be the total probability minus probability of success. That will be 1 minus 0.5, as simple as 0.5. Equally likely. Okay. And probability of getting exactly X successes in the end trial, where we can write as probability of X getting, for example, 5 number of hits. So this is what we call probability of random variable X getting the success of 5 hits. Okay, so these are all the fundamental things of how you can write your what we call experiment of binomial in terms of the notation. Okay, which goes back to the criteria of what we call binomial probability distribution. Any questions so far, class? Any questions so far, class? Because afterwards we are going to do a lot of calculation. Okay, so if you don't have any question, we proceed to the notation of what we call X binomial probability distribution. Now, knowing that your X random variable follow binomial criteria, for binomial criteria, so we can say X is following binomial distribution with the parameter. So this is what we call the parameter. Now, what are the parameters involved in the distribution? It will involve the number of trials, that will be the N, and the probability of success, that will be the P. So, class, can you still remember what is parameter, class? Class, can you still remember what is parameter? Someone, please. Someone? Someone is trying or want to try? Can someone try what is parameter? That we have discussed last time.
Tengok balik.
How do you forget? We just enter the second chapter and you forget first chapter. What is parameter refers to? Sample or population?
Population.
Parameter always refers to your population. So that's why in this experiment, if you say you have 10 trials, okay, that 10 trial is considered as your population. That's why we use the what we call the notation to the notation is referring to the parameter, whereby this experiment, okay, where we have experiment of 10 trials, okay, are considered as your population. Okay, so this N is what we call as the parameter of your experiment. So later on, you will see different types of distribution and it will involve again the parameter of that particular random variable. Now, other than X is binomially distributed with N trials and probability of success P, okay, this one is what we call the probability. Of course, when we are talking about X random variable, X following binomial, the ultimate goal is how to find the probability. Okay, how are you going to calculate the probability for this from this particular number of trials? Okay, so this what we call concept will help you out. Whatever number of trials you have for your experiment, so this particular binomial probability distribution help you out on how to calculate the probability easily. Okay, now you can use the formula. So this is what we call the formula. Formula to get the probability. Now, remember, probability of random variable x, x is defined by our success, is equal to any value, okay, is equal to the combination of number of trial and the x that you are looking for, multiply with the probability of success to the power of the number that you are looking for, multiply with the probability of failure. So this is probability of success. This is probability of failure. Okay. And the probability of failure is to the power of I'm really sorry, my extension wire sometimes got problems. So suddenly in my computer, everything blank. Huh? Okay. I'm really sorry for that. Okay, now this is what we call direct formula on how to find the probability. Okay, for 10 trials, what if I'm looking for probability of x is equal to 2? Okay, given the probability of success given to you, I can easily use this to calculate the probability. Okay. Other than that, what we should know about this probability, okay, we know that each and every what we call random variable will have its means and variance or standard deviation. So from this x random variable, we can also define the mean, the variance, and the standard deviation. Okay, how are we going to find the mean, variance, and standard deviation? Okay, so the mean for this particular x random variable following binomial is the number of trial multiplied with the probability of success. This will give you the mean. Okay, for the variance, denoted as variance of x is equal to number of trial multiplied with the probability of success and multiplied with the probability of failure. So you will get your variance. Square root this, okay, you will get your standard deviation. So square root the n multiplied with p multiplied with q, you get the standard deviation. Okay, so that would be the basic concept about what we call x following binomial with n number of trials and probability of success p. And this is how to get the mean, this is how to get the variance, and this is how to get the standard deviation. Okay, for the NCX, how are we going to calculate? You can use your what we call straight away your calculator. Okay, you have the NCR in your calculator, so this is equal to this one. Or you can calculate using calculator. Find what is n factorial divided by n minus x factorial x factorial. So n factorial means that if we are talking about 10 factorial, so you will have 1 multiplied with 2 multiplied with 3, 4, until multiply to the 10 value, 10 number. Divided by, let's say, x is equal to 7. So it will be n minus 7, it will be 3 factorial. So, sorry, 1, 2, 3 factorial. Multiply with x is 7. So 1, 2, until 7. Okay. So this is how you can calculate. But usually you just use your calculator. You can find this value straight away. But now, as far as my explanation is concerned, I want you to know, okay, finding the probability, I can straight away use this formula. Okay, and finding the mean, the variance, and standard deviation using the NPQ and whatsoever. Now, let us begin with the terms that you may find in the question given to you. And this term, okay, the reason why we come up with this is because understanding this concept seems easy to students, but when it comes to questions during the quiz, midterm exam, a test or whatsoever, this term become a chaos for many students because they don't understand what does it means by the terms at least, not less than, exceed, greater than, or whatsoever. So let us look at the what we call common terms that will be used in your questions. Now, your question will not be given straight away in this term. No, we are not going to give this to you. So most of the time, okay, what we will do, we will give questions sounds like this. Okay, for example, what is the probability that exactly 4 invoices? So exactly easy lah, is equal to. What about what is the probability that fewer? Okay, fewer easy again because it's just less than. What about at most? Maybe some of you may have thought, at most, is it greater than or equal to or less than or equal to? We sometimes confuse with the terms. Or maybe at least, for example. Okay, so in order for us to tackle these particular terms, okay, just to make sure everyone can understand it correctly and put it in terms of is it less than, greater than, or equal to, or in between these two variables or whatsoever, or is it this way or whatsoever. So this require you to understand the terms here. Okay, so the terms or the phrase greater than, equal to, at least, not less than refers to this one, greater or equal to. So greater or equal to can be not less than, at least, greater than or equal to. This one straightforward, you can understand, but this one sometimes we forget. Okay, because the term is in English. Okay, if in English it will be easier lah. Okay, next one, more than, greater than, or exceed. Clearly, it is the simplest one. Greater than, it will be greater than only, not including the equality. Okay, so not this one. Fewer than, less than, below than. Again, it's just less than. Okay, less than or equal to. Okay, clearly less than or equal to, or sometimes we call it at most or not more than. So it is referring to this particular symbol. Exactly or equal to, definitely equal to lah. Okay. Now, this will be the one that most students sometimes mess up with. Because once your terms, use your term, the terms wrong, definitely the answer will be wrong. Okay. So what does the term means from x1 to x2? This will be the phrase in terms of the mathematical symbol. For example, x1, for example, from 1 to, let's say, 3. So this should be written as probability of x, capital letter X, is between, is from, means that the 1 is included. From 1 until 3. Okay, 3 also included. So 1 until 3. Okay, included. Now, between x1 and x2, between means that you are talking, if let's say x1 and x2 is also 1 and 3, means that between 1 and 3, but 1 is not included, 3 is not included. So means that it will be, let's say in this example is 4. 3 is too small, the interval is too small. So not including 1 is greater than 1 but less than 4, for example. So p x less than 1, greater than 1, sorry, but less than 4. Okay, so this also means P, never mind, I'll just ignore this. Get the concept first, okay? Now, okay, what about between two? We know that 2 is included. Between n means that x1 and x2 is not included. Between x1 is not included to 2 is included. So that's why we have this term. From 1 and x2. From 1 is included, and x2 the same year, the x2 is not included. So please understand the phrase and the math symbol for each of the phrase, because it will give you a hint of what will be the terms here. X that you are referring for your given equation. Okay? Any question so far, class? Any class?
No question.
No question. Okay. Now, if you open your textbook, can you please open your textbook? Go to your textbook. Last page of your textbook, you have different types of table. Okay. For example, on page 197, you have your cumulative binomial probabilities. And then you have what we call Poisson, cumulative Poisson probability distribution. On page 206, you also have what we call T distribution, standard normal distribution, and whatnot. Okay, so we are going to use this in your calculation. Okay, now, sorry, I have all my 4 kids are at home. They have their what we call online class, so the only option is doing my online class for me is in my bedroom. Okay, I don't have any table. So now, I want you to understand the terms cumulative probability distribution. Okay, class, we know that we can find or calculate the probability for exactly. For example, there's this one. Finding the probability of exactly the random variable is equal to one certain value, you can always use this to calculate. Okay, but what if the number of trials and the probability that you wish to find is larger than what you are expected? So this is where the cumulative binomial probability distribution is very important and useful for you. Now, say we in your example, if I'm not mistaken, the example, I'm now referring to what we call page 48. Okay, page 48, the first phrase involve all these phrases. Okay, now, before I can go into these particular phrases, okay, assuming that all your equations can be what we call defined using these particular phrases. Okay, probability x is equal to certain value, probability x is less than certain value, greater than certain value, and so on and so forth. Now, let's say we take the example. And the example in your book on page 48, example 2.7. Okay. On page the coin is 3 times. I change the number of trials to 10 trials so that I can show the reason why using the cumulative binomial probability distribution will be important in order to find the probability if the number of that value will be larger. Okay, larger than what we are expected. Now, if we are talking about 10 trials of flipping a coins, okay, we know that this is following binomial with the parameter of 10 and we know the probability of success. Let's say in this case, in your example is getting the heads, okay? Getting the heads, okay? Getting the heads, the probability of success is 0.1, okay? Now, the reason why I choose this to be in one slide is because now, if let's say you wish to find what is Px is equal to 2, you can directly use this formula and you just use 10C2 0.5 to the power of 2, 0.5, the probability of failure to the power of 8. Okay, you can simply use your calculator, you get the answer. Okay. Also, x is equal to 9. You can also use 10C9, 0.5, 9, 0.5, 1. You can directly get your answer. What if you have question such as this? Or such as this one. Let me begin with x less than 2. What does that mean? Remember class, when we say 10 trials, we know that x will take value where the x, this is small x, will take from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each and every, what we call x, small x, will have its own probability value. For example, just now x equal to 2, this is the probability. This is number 1. Okay, x is equal to 9, this is number 2. Now, when we say x less than 2, means that we are talking about Px equal to 0 plus Px equal to 1 plus Px, no, less than 2, 2 is not included. So we stop at x is equal to 1. I want you to understand this. Okay, class? So if you have Px less than equal to 2, means that you have two probability that you need to consider to find your probability of x is less than 2. Can everyone understand this, class? Class?
Yes, understand.
Okay,
Yes.
thank you. What about Px less than 4? Means that you will have to include and sum of the probabilities from 0 until 4. Px is equal to 0 plus Px is equal to 1 plus Px is equal to 2 plus Px is equal to 3, because including 4 plus Px is equal to 4. So this is what we call the cumulative. Later on, we will base on the table that we have, and that table says about cumulative. So that cumulative reflects this. This is what we call cumulative. Oscillator. And of course, when you say find the probability of x less than or equal to 10, okay, definitely the answer will be equal to 1. But this one reflects the Px is equal to 0 until the last one, Px is equal to 10. Okay, so that will be your, what we call, the things that you should understand about the cumulative for binomial probability distribution. Now, since we have these phrases, okay, and it is good for you if you can understand why these phrases is very important. Okay, why are they very important? For example, if let's say Px that you are looking for is equal to 3, means that you are, instead of having these just now, all these phrases included, you can just use 1 minus, probability of x, okay, probability of x is less than or equal to 3 minus, before equal to 3, it would be px less than or equal to 2. Okay, this, why we are discussing about this phrase, because we need to understand this is the concept if we are using the binomial table. Because the binomial table says about the cumulative of the binomial probability distribution. Okay, so if you are talking about find the probability of x less than 3, means that you are saying find the probability of x less than or equal to 2. You have 0, 1, 2, 3. Less than 3. So 3 is here, but 3 is not included. Less than 3 means that 2 and below. Okay, exactly 3 means that finding the probability from 0 until this is p x less than or equal to 3 and minus blue one from here until here is px less than or equal to 2. Subtracting the probability value from these two, you will get exactly at 3. That will be exactly at this one. Okay, now the same goes to if I have, let's say, px greater than 3. Okay, why we are focusing, if you can look everything here, the notation is using this. Why this? Because if you can see from your table of binomial, we are using this term. So all the value inside here are using this, what we call px less than or equal to the x1, xi, or whatever things used. In this case, we are noted as the k. So that's why, if in order for you to use the cumulative binomial table, we form all the terms in terms of less than or equal to. Okay, so that it will be easier for you to calculate the probability. So go back to hit this. If I have, let's say, 10, from 0 until 10, 0, 2, 3, 4, 5, 6, 7, 8, 9, 10. Says that x greater than 3, but not including 3, means that from here to here. Okay, so since the probability cumulative table says about this less than or equal to, so focus on the area where we can use the table for. Okay, so in this case, that's why it turns to be, okay, 1 minus px will be less than what? Less than or equal to 3. Because greater than equal to 4, okay, 4. So greater than 4 means that from here to here. So in order to use the table, it will fulfill this term. So it will be greater than 4 is from here until here. So greater than 4 but not including 4 is actually 5. So 1 minus px less than or equal to 4. Okay, because we are beginning from 5, so 4 is included for this particular table. Okay, just listen and later we will see a few examples. So hopefully you can understand further the how we can form these phrases in order to what we call answer the probability questions regarding the binomial probability distribution. The same goes to if I have p x greater than or equal to 4. Just now 4 is not included, but now 4 is included, means that it must be greater than or equal to 4 from here. Just now is from here only. Now greater than or equal to 4 means that 1 minus p x less than or equal to 3, because since 4 is included, so we are talking about this region. Okay, we are talking about this region to be the answer for this one. Okay, this one. Now, the next term will be probability of x is from, let's say, 1 until, or the phrase just now including would be 2. Okay. Okay. Let's say 1 until 3. So this will be px, okay, less than or equal to 3 minus px less than or equal to 0. Okay. So, and finally, I'll just give a few examples. Later we'll do the exercise. Hopefully it will be clearer. Okay, so if I'm talking about 1 is x is greater than 1 but less than 5, for example, so you will have p x less than or equal to, because 5 is not included, so you start with 4 minus probability of until 1. Okay, so this is means that if you can't understand, just understand how this phrase is formed into this particular phrases. Okay, any questions, class? These are just few examples theoretically. Okay, later we'll see how we can solve the equation for this particular relating to this particular phrase. Now, let's say you look at your example 2.7 on page 48. Okay, as I mentioned just now, in the example, tossing a coins only involving three times only, but I change to 10. Okay, so I'm referring to n trial. Okay, 10 trials. Now, is this binomial experiment? So first of all, when you get your questions, check whether it fulfills the criteria for binomial. If it does not fulfill the binomial, it could be Poisson. Okay, if it is not Poisson, it could be continuous. Okay, so you have only 3: binomial, Poisson, continuous. Of course, there will be approximation binomial to Poisson and whatsoever. So we'll see different why we can approximate that. Okay, but bear in mind, once you get your questions, check the criteria, which criteria the question fulfill. Okay, so if you are checking for binomial, then check for all 4 criteria that you have. Okay, so what is the random variable in this particular example? So the random variable is the number of getting hit when tossing 10 times. And we can write the distribution as this one. Now we are trying to what we call solve these equations. Okay, now I want everyone to find the probability if we are using the formula. Okay, so for x following binomial with 10 number of trials and probability of success is 0.5. So if you are using your what we call formula, so it will be px is equal to 2, 10 c 2, 0.5 to the power of 2, probability of failure 0.5 to the power of 8. Can someone give me the answer? 10 combination of 2 multiplied with 0.5 to the power of 2 multiplied with 0.5 to the power of 8. Can someone give me? I'm waiting for your answer, class.
0.04.
Huh?
0.04.
0.04. Can someone confirm?
Yeah, 0.04. If round off 0.044.
0.044.
Yeah. If round
Is it correct, class? Correct?
Yes, yes.
Yes.
Yes, correct.
Yes. Yes.
Right. Now, if this is using your direct calculation using the formula. Now, what if I'm using my probability distribution function? See, cumulative binomial probabilities, and there will be the P, the probability of success given in your textbook. So if you can check, can you just find your probability for probability of success 0.5? On what page is that? I'm referring to your textbook. What page is that? Find for probability of success is 0.5. And the number of trials n is 10 because we are using 10 trials. Can someone give me on what page? Page 202, right? Class?
Yes, page 202.
Yes, page 202. Because remember when you refer to your binomial table, please look at the number of trials that you are looking for. Look for the number, the probability of success that you are looking for. So this is your P that you are looking for, which reflect your experiment, 0.5. Okay, now, if we are using our formula here, using the table, so P of X equal to 2 is P of X less than or equal to 2 minus P of X less than or equal to 1. So where can I find X less than or equal to 2? Now, from n number of trial, this is your K. Your K in our textbook, we use as K1, X1 and X2. So we are talking about 2. So looking for 2 and go to your respective probability distribution function. So we will have 0.0547. So let us check whether this is correct or not. It should be the same if you correctly count the value. So Px less than or equal to 1 is 0.0107. So what is the value here?
0.044.
Yes, 0.044. So now you already know for binomial probability distribution or for any random variable that follows the binomial distribution, I can use my formula to calculate or I can use my table of binomial. So when we say cumulative, see this one class, in this box, this is referring to, let's say, Px less than or equal to 2. Means that it is Px equal to 0 plus px equal to 1 plus px equal to 2, since 2 is included. So that's why we take whether 2, the probability of cumulative, this is px less than or equal to 2. And this one is px less than or equal to 1. So it will be easier for you, right? So when you are doing a trial, large number of trial, for example, 100, n is 100, and you are looking for the probability of px is equal to 50. You're not going to use this to help you out in finding the probability value, but definitely the table will ease the process of finding the probability. Okay, so that will be the first question. Now, what about px less than or equal to 4? Okay, so for px less than or equal to 4, okay, in theory, it will be px equal to 0 plus until plus px equal to 4, because 4 is included. But if you are using your table for n trial, 10 trial, for probability of success 0.5, and we are talking about 4. Look for 4 and go for the probability value. So you will have px less than or equal to 4 minus px less than or equal to 30. In this case, directly from your table, because the probability is asking this probability. Okay, so definitely straightforward using your table. So this will be what? 0.3770. No need to calculate anything. Just look at the table, because this is given for less than or equal to 4, including all this. Any question, class? Class, any question? Don't miss out, eh?
Okay, doctor, no question.
No, doctor, no.
Okay, thank you. So if that is directly x less than or equal to 4. Just now is exactly 2. That's why we deduct 2 with 1, because we want to find only at 2. Now, less than or equal to 4 means that I'm looking for all this. Okay, that's why we directly use the given value in the table as the answer. Now, what about px less than or less than 3? Does 3 included in your calculation? No, right? So if no, then you can directly say x is less than or equal to 2. Means that from 0, let me use blue color, from 0, 1, and 2 will be included in your calculation. That's why for this one, the answer would be, okay, is 0.0547. As simple as that. Okay, class? Okay? Okay. What about what about px greater than 3? Remember, our cumulative table talks about this. So we have to modify our what we call terms greater than 3 to follow this particular less than or equal to whatsoever number that we have. So for this one, it would be what? Looking at your phrase just now, greater than this one, it will be 1 minus this one. Okay? So greater than 3 means that 1 minus px less than or equal to. So in this case, it will be 1 minus px less than or equal to 3. So it would be 1 minus, look for 10 trials, 0.5 success, and you are referring to 3. Okay, so you will have 0.1719. Okay, so you will have 1 minus 0.1719, so you will get 0.8281. Okay, class?
Okay, doctor.
Okay,
Okay.
if you can check, if you want to check, you can find 1 minus px equal to 0 plus px equal to 1 plus px equal to 2 plus px equal to 3. Check this, whether you get the same answer, but of course, you're wasting your time because everything has been simplified for you. Just use the defined phrases in order for you to get the probability value. Now, what about when x is greater than or equal to 6? Can you find, class? Why don't you try? Find probability of x greater than or equal to 6. So, greater than or equal to 6, it would be 1 minus, what's this one? Can you try, class? Can someone give me your answer? Anyone who got the answer? So it would be,
0.377.
okay, hold on. 1 minus, since 6 is included, so you are talking about, let's say 5, 6. So greater than or equal to 6 means that you are looking for this one. So it means that it will be px less than or equal to, because 6 is included, so we are talking about 6 minus 1 will be 5. 1 minus p, x is equal to 5, less than or equal to 5. Okay, 0.6230. What was the answer just now? Who gave me the answer?
0.377.
770. Okay, easy, right? Okay, but this kind of question is always being asked in the assessment. So sometimes it will go back to your understanding of how you can use the table. Now, what if we have these two? Means that it's between 4, 5, 6, 7. Okay, you are talking about 4, including 4 until less than, so you are talking about this area. So what would be, how are we going to find this particular answer? So px between 4 to 7 will be what? Px less than or equal to 7, right? Minus px, because 4 is included, so it would be what? X less than or equal to 3. Is it correct? Okay. So x2, x1 minus 1. Okay. So from your table, x is equal to 7. 0.9453 minus less than or equal to 3. You will get this one, 0.1719. Okay, what was the answer? What will be the answer here, class? 0.
7734.
Okay, so this is how we get the answer. Now, what if the number, the value is not included? We are talking about 4, 5, 6, 7. Less than 7, Means that, yeah, greater than 4. Definitely 5. So in terms of notation, it will be Px okay. It will be Px. If you go to the phrase just now, it will be x2 minus 1, right? So it will be less than or equal to 6 minus Px less than or equal to 4. Okay, so in this case, 6 would be 0.8281 minus 4, 0.3770. So what will be the answer here, class? 0.4511. 4511. Okay, so that's how we can use our probability distribution table in helping out on the calculation of what we call your probability value for certain random variable value of x. Okay, now from your example so far, I think I have covered. Okay, now before we proceed, let us find what would be the mean. Okay, what is the mean? Okay, we are talking about the mean of the experiment. We are talking about the mu, or the expectation of your random variable x is what? N multiplied with p. That will be 10 multiplied with 0.5. So your mean for this particular random variable would be 5. Okay, means that the average for this particular random variable or the mean is 5. Okay, and the variance is NPQ, right? So NPQ 10, 0.5, the failure is 0.5, so it would be 2.5. What would be the standard deviation? Okay, sigma square root of 2.5, you will get what?
1.58.
What was that?
1.581.
1.5. Okay, now everything will go back to your mean, variance, and standard deviation. Okay, so far that is how binomial experiment and how to find the probability for that particular binomial distribution function, probability distribution. Okay, if you don't have an equation, let us move to the next example. Okay, so this is the question that always being asked during your assessment. So the question will be given in terms of what we call sentences, not in terms of mathematical form. Why? Because we need to make sure that all students can formulate from the what we call sentences of statistical problem to the mathematical function before student can even solve the question. So it will show how students understand the concept of probability. Okay, so a large industry firms allow a discount on any invoice that is paid within 30 days. So means that invoice paid within 30 days will get discount. Okay, so understand that any company that give the invoice in within 30 days, for example, in the 29 days or the first day or the 15 days, so they deserve discount. Okay, of all invoices, 10% receive discount. Okay, 10% receive discount. Means that 10% receive this discount. Okay. In the company audit, 12 invoices are randomly selected and independent of each other. Means that invoice from company A and invoice from company B are independent. Okay, so it depends on the days, the days that the invoice given to the audit company. So how can we extract the information that will be in terms of binomial probability distribution? So the first one that you will have to identify from any given question is what will be the definition of X used in this particular example. So you have to be very meticulous in terms of looking at the given information. Okay. So of all 10%, of all invoices, 10% receive discount. Means that the probability of success referring to those who got the discount. So X will always be the number of invoices in the sample, or if you don't want to say in the sample, it's also can in the sample receive or that receive discount. How many percent? 10% discount. Okay, so that will be the definition of your instance, or that would be what will be the probability of success? That would be the probability of getting this point. So your X is binomially distributed with 12 number of trials and probability of success 0.10. So once you have this, double check. Have you got your probability of success? You got number either correct or not. Okay. So this one is question number 1. Now, the probability is therefore, okay. So if you look at your binomial table, now we talk about the probability of success is 0.1. The number is indicator, and this is the okay. Now the first question. For the calculation using the Excel, that was everything understood for the beginning, because your understanding for like normal. This question is finding the probability of X is equal to Z4 invoices. So this will be Px less than or equal to 4 minus Px less than or equal to 3. Okay. So in the questions, in the example, the Excel is used. Okay. You can try on your own. Okay. So let's look if you are using the table. For number of trials, 0 0.997 minus less than or equal to 3. Can someone calculate that? Is it 0.0213 plus? Right? Hello?
Yes, correct.
Are you all with me?
Yes, correct.
The second question. Okay, thank you. At least I can hear one voice that it will be enough just to make sure it's correct. Then what is the probability that fewer than 4 invoices of scheme? So now you are looking for less than 4. So less than 4 means that Px less than 4 means that theoretically it is Px is equal to 0 plus Px is equal to 1 plus Px is equal to 2 plus Px is equal to 3 because less than 4. But using the binomial distribution table, you can just simply Px is less than or equal to 3 directly. So because not is not equal directly or equal to 3. So it will be 0.9744. Is it correct in your textbook? Okay, yes. Okay, so directly from you will get 0.9744. Question. Number 2. This one is number 3. Now, at most 4. At most 4, directly from your table, it will be 0.9957. Okay, X is 1 plus X is equal to X is how many terms you have? 1, 2, 3, 4, 1 terms. 1. You are using your binomial table, you just can directly get the answer. Now, what will be the next question? So, what is the probability that more than 4? Okay, more than 4. Number 4, Px more than 4. Okay, so if we understand, we have 4. More than 4 means 5 and above. Okay, so 1 minus Px less than or equal to 4. Right. Am I right? So it will be 1 minus less than or equal to 4, 0.9957. Can someone calculate for me? 1 minus 0.9957, what's the value?
Zero point zero zero
0.0043. If you go to your textbook, says 9956. Your textbook got some difference with my table. So in their textbook is 9956 if I'm not mistaken.
So why the table Excel is different from this book?
Different in terms of what?
Like in the example, it shows the table generated using Microsoft Excel, but the value is different if we look at the back, the book.
Yes. Now, in the Excel, okay, now, let me clarify one by one first, okay? In your textbook, the calculation for px less than or equal to 4 is given by 0.9956. But in my table, is your table inside your textbook same in mine or not? Binomial 12. Probability 0.1, 0.1 for 12, 4. Okay, I think, okay, now, in the Excel, if I can snap the picture, in the Excel, I something, let's say I don't think that's sini. Now, you need to understand the Excel is different. The Excel is calculating for exact value of your, what we call probability. Okay, the Excel shows, so this is your Excel. Let me use my black pen. Okay, this is from Excel. What happened in Excel? You have your X and you have your Px is equal to X. Right. So the number of trial is from 0, 1, 2, 3 until your 12th trial. Right. But now the difference is this. Okay. This is exactly what if Px equal to 0. You will get the calculator in your Excel will give you, it will be 0.2824. Okay. Now, this refers to x following binomial with 12 and 0.1. Okay. For Px is equal to 1, the probability is 0.3766. Okay. So for P equal to 3, x is equal to 3, it is 0.2301. Now let us look at one example, simple example. Now we choose this one. Okay, x is equal to 4. Now let me add 4 for equal to 4. Px is equal to 4. It is 0.0213. Is it same? Same, right? Those who just ask me, same, right? Exactly 4 is 0.213, right? So you get exactly at 4 is 0.0213. So the Excel specifically find the probability for each and every value of your X. So until, if you follow until the 12th value, the probability is 0.00002, too many zero here. If you add all these, you will get 1. This is the summation of all Px equal to xi. Okay, so these are all the summation for Px, where x equal to xi equal to 1.0, the maximum value. Can you understand, class? Understand, class?
Yes, doctor.
Okay, thank you. Now, let us finish with the question so that you will get a clearer picture of all the calculation that you need to understand, because afterwards when we go into Poisson, especially the normal distribution for continuous probability distribution, which is more complex than binomial and Poisson. So this kind of concept, the whole thing about less than, greater than, whatsoever, are very important for you to answer, because continuous probability distribution is much what we call complex compared to the binomial and Poisson. We have, it's already 3:14, so I think I'll just finish with the questions. In the next class, I will cover until Poisson, because we are, I think, a bit late from the date. Okay. Question number 5, more than has been answered, right? This one is number 5. Okay, and then what is the probability at least 4? That would be question number 6. Okay. Number 6, find the probability X. What was the question? At least 4 invoices. So at least means that PX greater than or equal to 4. We are talking about 4. 4 is included. Greater than. So it will be 1 minus PX what? Less than or equal to 3. So 1 minus 12, 3, 0.1. So you have 1 minus 0.9744. So you will get, I guess, 0.0257. Okay. And finally, the last question, find and interpret the mean and standard deviation of the random variable X. Now, this is the common questions where we measure student understanding of how to define or how to interpret your X random variable based on all the calculation of probability that you search. Now, the final question asks about the mean. Okay. Mean, so simply the n multiplied with p, n is 12, p is 0.1, so you will get 1.2. The variance, okay, that would be sigma squared npq, so 12, 0.1, 0.9, that would be 1.0. So the standard deviation would be square root of 1.08, that will be 1.04. So how do we interpret this value? Okay, how do we interpret this value? Okay, remember we have 12 invoices. Okay, so for the process of selecting 12 invoices, okay, or if I were to just follow exactly what is being put for you in terms of how to find. For selecting 12 invoices, okay, from the 12 invoices, okay, the mean number of invoices they receive 10% discount is 1.2. Okay, and the variance, with the variance, variance 1.08 means that out of 12 invoices, what will be the average number of invoices will get 10% discount is 1.2. Average there will be 1.2. Or say we can say only one invoice will receive the discount. Okay, so very small probability, right? Okay, class, do you have any question before we start? regarding your what we call your project or your whatever materials that you have to submit. I have started receiving your project, okay, yesterday. I hope those who submit your project will give the slide in PDF where each page will contain 2 slides. Second, followed by the video presentation. And the third one is the Excel file for all the calculation for the objective of your project. Okay. Before we stop, do you have anything to discuss or? So please, if you have time, please go and look at the questions, tutorial questions. Okay. So beginning from next week, for the night class, I'm going to do the night class. I'm not going to give you any video whatsoever because I found it it is a bit late for me to cover all the materials if I give you the video for you to watch. Okay, so starting from next week, we are going to have the night class. Okay, so I'm going to do online class as well. Any objection for that?